Hi all, I'm Angad. Welcome again. This is the first session of Whiteboard. And in this session, we are going to discuss what is artificial intelligence, what is data science, what is machine learning, what's the difference between these, as well as we will discuss some of the career options. 21st century is the century where we had revolution in information, and that revolution is still going on. Every organization, big or small, is generating huge amount of data. And every company will eventually be in data business, whether it is in any of these sectors, whether it is in healthcare, entertainment, agriculture, fintech, tourism, sports, telecom, social media, any of these sectors. So, for example, in healthcare, we can have research on vaccines, getting through to the past data. We can solve some of the world's problem. For example, we can work on diseases like cancer. In entertainment, Netflix, Amazon Prime, all these huge streaming giants, they are using great kind of analytics. They are using some of the recommendation systems where they are finding the trend pattern of what we are consuming, and they are giving us those recommendations based on our consumptions. Then you have agriculture, where there is a huge amount of automation done in agriculture, in fintech, in tourism, even in fields like sports. For example, FIFA World Cup, Wimbledon, AI was used in all these kind of sports. They know the strength and the weakness of players, um, the opponent. Like they do a lot of analytical work in the background to understand each and every aspect of the game before they enter the field. So, in short, in 2022, the world has produced and consumed 94 zettabytes of data, and that's huge data, right? That's a huge amount of digital data which we have, and data in physical world is even more than this digital data. So the statistics which you can see over the slide here are of Jan 2022. Right now we have 8 billion population in the world, but in Jan 2022 it was 7.91 billion, and out of which 5.31 billion unique mobile users were there, 4.95 billion internet users are there, 4.62 billion active social media users are there. So you can see the boom of the digital world, like the boom of internet, the boom in communication industry, how we are generating this huge amount of data. And the data which is being stored in those databases, data warehouses, are being used for analytical purpose. So the agenda behind this slide is I want to showcase that how artificial intelligence, machine learning, and data science are part of our day-to-day routine, are like how industries and each and every sector are using the data, and are in the data business. What do we mean by data science? So once we have that big data, once we have that large amount of data, how we can extract meaningful insights for our business, how we can solve some of the problems for our business as well as for our society by interpreting that data, by analyzing that data, by creating the patterns out of that data. So what we need to become a data scientist, like which all fields, which what knowledge should we have? So we should have knowledge on mathematics, we should have knowledge on statistics and algorithms. Like knowledge of statistics is very important for data scientist. He should understand how he can interpret the data, which are the statistical techniques that he or she can use on the data. Programming knowledge. So once statistics is combined with programming, how we can create those intelligent programs, how we can create those models, how we can do some of the analytic or analysis kind of work to interpret the data. So that's the programming knowledge. A data scientist or a data analyst should also have a good knowledge on business and communication. He or she should understand the functional business problem very quickly, should take the feedback from business owners, and should be able to communicate well back to the business, right? So it's a continuous cycle. Like you showcase something, you get the feedback, you modify it, you showcase again, and then you take those feedbacks and inputs to make sure you solve that problem. One should have a good data wrangling skills, should be able to play with the data, should be able to mine the data well, should be able to visualize the data. And then mathematics is again very important. Like one should understand, one should have a good knowledge on algebra, one should have good knowledge on probability and lot of mathematical techniques. So once you learn data science, which are the roles in industry after education? So you can be an analyst. So you can be a BI analyst, data analyst, business analyst, expert analyst, or consultant. So business analyst and consultants are more towards the business side. Like they will understand the business problem. They will come out of, they will create some of the solutions. They will interpret the data, and in their solutions they will put up like what are the insights they are getting from that data, while BI analyst and data analyst are more inclined towards the data side. They will use tools like Power BI, Tableau, etc., data warehouses, data lakes to interpret the data. Then you have statisticians. A statistician can be theoretical statistician, mathematical statistician, experiment designer. Mostly I have seen that in the organization you only have a role as statistician, right? And mostly the statistician should have a knowledge on mathematics as well, right? So when I talk about mathematical statistician should have knowledge on probability theory. He should understand what are the samples, what are the populations, how can I use some of the mathematical techniques to interpret the results. Then you have engineers. So you have data engineers. So data engineers are basically creating those data pipelines. Data engineers are basically having a knowledge of SQL. They should have somewhat knowledge of cloud. They should have some knowledge of automation. So how they can use the data and create, like I said, data pipelines, which we will of course discuss in our later videos. And then you also have data architects who understand which are the key components which has to be used by data engineers. So they create that architecture or framework. Then you have a role like data scientist, research scientist, robotics scientist. So data scientist, as I said, like he or she should have understanding on all these fields to be a good data scientist. Research scientists, so some of the organization hires data scientists to work on research projects, which they call it as research scientist. They are working towards a research, like that focused group is working towards a specific research project. Then you also have robotic scientists. So in manufacturing industry or in automobile industry specifically, you will see such roles like robotic scientist, where you have physical mechanical robots, and then you use some of the AI or data science techniques to make sure those robots are aligned towards the problem you want to solve. Then you can also go in academics. So you can be a research intern, lecturer, or a professor based on your interest. You can also publish research papers, you can write blogs. Again, like for me, if you ask, I have a lot of interest in academics as well as I want to contribute in the industry and solve some of the real-time business problems. What is machine learning? So machine learning is basically a field of artificial intelligence. So imagine how a child learn, right? So once a child is like, when a child is 2 years old, a child learns from the labels. He will say Papa, Mama, Dada. Maybe he will identify a television, a tube light, a bulb, etc. So a child will learn from the labels. And once a child is 2.5 years old, he will have 200 to 1000 words in his vocabulary. So that's supervised learning, how we can learn from the labels around us, how we can label each and everything, which is known as supervised learning in terms of machine learning. So machine can also learn from the labels. Machine understands, okay, this is a notebook versus this is a pen versus this is a table. Then you also have something known as unsupervised learning, where you don't have those labels. You have a lot of data, but it doesn't have those labels. So imagine if I give few of the things to the child and I don't label it, like I put some of the vegetables and fruits, and then I ask child to segregate it. So a child can segregate that, can create clusters based on the features, like this is a fruit versus this is a vegetable, etc. That's how we cluster in supervised learning as unsupervised learning as well, where we see the features of those data points, and then we cluster it based on that. Then you have something known as semi-supervised learning. So in real world, it won't be a pure supervised and it won't be a pure unsupervised. Mostly in most of the cases, it's like semi-supervised problem. So when I say semi-supervised problem, it's like some of the data is labeled while the other data is not labeled, right? So there is a technique known as pseudo labeling, where you can label some of the data which is not labeled using some unsupervised machine learning models. And once you label everything, then you can use supervised machine learning models. Then you have something known as reinforcement learning. So reinforcement learning is, just for an example, again taking the analogy of or example of child. If child does something good, you will give a goodie to the child, right? You will, and if child doesn't show the right behavior, you will punish the child or you will give the feedback to the child. Similarly, if a machine does something good, if a machine shows a right behavior, you will give some bonus points to the machine, right? That's like you are reinforcing the right behavior. Typically in self-driving car, right? You are reinforcing the right behavior on the machines while you are creating those self-driving cars. Again, which are the various roles in the industry? You have machine learning consultant, you can have machine learning engineers who can create those machine learning pipelines. They can deploy those machine learning models in production environment. They can create those machine learning algorithm as a start. They understand, like each of these, like when I discuss supervised learning and when I discuss classification and regression, each of these field will have various algorithms, and we are going to discuss, there are multiple algorithms, like so many algorithms, and we are going to discuss in our future videos. Then you have machine learning engineers, architects, as we discussed, and then again in academics, like you can write some of the great research papers, you can spread your knowledge on machine learning. What is deep learning? So imagine I'm looking like this is a charger in front of me, right? And my retina is basically giving signals to my nervous system, and my nervous system is identifying that, okay, this is a charger or this is an adapter. Similarly, if we have to mimic the human brain, it's known as deep learning. So deep learning is based on artificial neural network. In our brain, we have biological neural network. How we can create artificial neural network and layers so that we can identify. So for example, I can identify this is a dog versus this is a cat via artificial neural networks. And again, we are going to discuss, like each of these topics, guys, is like is very deep, and we are going like to discuss each of these topics in detail in our future videos. What is natural language processing, right? So we humans, since the start of civilization, one of our biggest achievement is we can speak and we can understand. Basically, we can communicate. We can communicate via simple, plain language. And right now we have so many languages, like over 5,000 languages, known languages in the world today. Can machine also understand a human language? Can machine interpret a human language? Can machine understand spoken and written both kind of language? Can machine also generate the language back to you after understanding? Answer is yes. That's the field of natural language processing. Again, natural language processing is part of artificial intelligence. Natural language processing has two main streams. The first stream is natural language understanding, where machine or natural language interpretation, where machine is understanding and interpreting what you are saying or what it's reading. So for example, you have chatbots like Siri, or you have virtual assistants like Alexa or Watson. They will understand what you are saying first before they answer back to you. So that's human to machine. And then you have machine to human, which is natural language generation. So once they interpret it, they will generate the natural language back, right? So that's natural language processing. Then we have something known as computer vision. So we humans, we have our eyes, and through our eyes we can identify and interpret so many things. So similarly, can a machine interpret all those things? The answer is yes. It's the field of computer vision. Like only in automotive and manufacturing industry, this computer vision field is around 48.6 billion USD market. So you can imagine this is a huge market in itself. Which are the various use cases? So image generation. And I saw like a good software named as DALL-E. Like even if you want some funny images to be generated. So for example, you want an image of panda reading a book or a zebra on a tree. All those kind of funny images can be generated via artificial intelligence. So you just have to tell what you want and AI will generate that image. You can have entity and object recognition, like this is a car versus this is a person versus this is a traffic light. You can also have a scene analysis. So this is a scene, right? So for self-driving car, it's a scene basically. There are so many parameters. Some of them are very static while the others are moving across the dimensions, right? So traffic light, it's a static parameter, but then humans or other cars are moving in multiple dimensions. And it's very important for computer vision system to understand that scene via the sensors and to interpret that scene, right? Document understanding, so you have PDF documents or you have handwritten documents. You can understand those scanned copy of those documents. So imagine there are so many contracts which are buried under some system. You can gain some important information out of those PDF or handwritten documents or contracts, right? Or imagine the doctor prescriptions. So many scanned prescriptions are there in the hospital based on the diseases someone is having. You can get all that natural language via computer vision, right? Video recognition and understanding. So for example, in YouTube, they are analyzing all the videos that are being posted on YouTube. So there are algorithms which are scanning all those videos, right? So you can also do video recognition and understanding via computer vision. Now that we have defined data science, deep learning, machine learning, NLP, computer vision, let's discuss what's artificial intelligence, right? So artificial intelligence, that word was first coined in 1955 by John McCarthy, while Alan Turing is known as father of artificial intelligence. So in 1950s, Alan Turing did this simple experiment. So basically there is a machine and there is a human, and human is interacting with machine and machine is answering back. That was a simple experiment, and based on the answers, the accuracy was being checked. So that was known as Turing test. And Alan Turing also wrote a paper on intelligent machines and how intelligent machines can be the future, right? So we are going to interpret that article as well. But in general, what is artificial intelligence as a definition? So it is a science and engineering of making intelligent machines, especially intelligent computer programs. It is related to similar task of using computers to understand human intelligence, but AI does not have to confine itself to the methods that are biologically observable, right? So till till 1990s we mostly had, or late 80s we mostly had symbolic AI. So symbolic AI is high level symbols. So for example, Angad is driving a car. Angad is a symbol. Car is a symbol. Driving is a relation, right? So it was it was imagined that the universe constitute of so many symbols, and then there are relations between that symbol. But later on, people realize that intelligence is more than these symbols, right? Like more than the rules, more than the semantic nets, more than the expert systems which we have generated via those symbols, right? So then we had more development in neural networks, and now we have transformers and so many other techniques, which are, some of them are also sub-symbolic AIs. What is neat versus scruffy? So neat is again based on the logic, based on optimization, based on neural networks, right? Scruffy is basically how I can take some of the unrelated problems which are not related to my current problem and commonsensically relate those unrelated problem to my current problem, right? And then there was a paper which was being written by Russell and Norway, termed as victory of needs over scruffy. Okay, the next one is more philosophical. So it's the philosophical side of artificial intelligence. Like, what is ANI versus AGI versus ASI? So ANI is basically artificial narrow intelligence. So we humans are basically the benchmark for any AI machine. So if AI is having less intelligence than human, then you will put that in artificial narrow intelligence. If it is having equal intelligence as human, then it's artificial general intelligence. And if it is having more intelligence than humans, then it is artificial super intelligence. And I was just going through one of the interviews of Elon Musk, and he feels that after few years, AI bots and AI machines will have more intelligence than the entire human civilization, right? Because of the huge progress we are making with neural networks, with computing power, and even with quantum computing, and so many fields, right? That he feels that after few years, we will be somewhere in ASI. Soft computing versus hard computing. So soft computing is again like, it's based on fuzzy logic, it's based on real time problems. Normally we have noise in the data. It's not always we will get data without noise, and then we have to process that data via some logic to get through some interpretation. While in hard computing, like, it is being assumed that the data is not having any noise, and then you have to interpret or you have to compute that data. Consciousness, again a great topic, a topic where the research is going on right now. So we humans, we also have a sense of self-awareness. We can feel, we have emotions. Do machine have consciousness? May not. We, like, machine right now don't have consciousness, but it's the field of research, as I said. Like, intelligence in itself is having a huge spectrum. Like 3 multiplied by 3 is also intelligence, and solving general relativity, some of the problems of general relativity is also intelligence. There is also intelligence of emotions, how we answer back to our colleagues, to our customers, to our family members, how we show sympathy, how we show empathy. That is also emotional intelligence. And good leaders, like, they have both sides of mind, like logical intelligence and emotional intelligence. And how we uh, can machine also show or display that level of intelligence? Can machine also dream like we human dream, or we have some subconscious mind? Like, that's a field of research which is going on. So going back to some of the important timelines, In 1940, Enigma was decoded by AI. So it was decoded by Britishers against Germans, and it was a victory of Allied forces. Like Enigma was a major breakthrough of Allied forces, which they broke via artificial intelligence in 1940s. In 1950s, and Alan Turing was great. Like Alan Turing was the main scientist who helped in breaking Enigma. In 1950, he did a Turing test. 55, we coined the word AI. 61, there was introduction of Unimate, the first industrial bot. In 1964, there was the first chatbot. Then there was a first chess playing program. Now, chess in itself is very complex game. Like there are more permutation of game of chess than the sand particles in this universe, than the atoms in this universe. So imagine that there are so many permutations of the games of the game which is possible, and an AI bot is playing that game. In 1979, the first autonomous vehicle was created by Stanford Cart. In 19 like later on, Deep Blue chess machine defeated Gary Kasparov. In 2004, NASA's robotic exploration rover Spirit and Opportunity autonomously navigate the surface of Mars. Like AI bot can navigate through surface of Mars, giving some of the information of the land of Mars or of the terrain of Mars back to the humans, and interpreting some of the scenes via computer vision, right? So that was a great achievement. In 2011, IBM Watson was created, and you can see so many videos of IBM Watson on YouTube as well. 2022, OpenAI created GPT-3, general purpose transformers, again a great breakthrough in the field of machine learning and artificial intelligence. Now, as I said, the agenda of this session was how we can bring everything together. Like people mostly use AI, data science, machine learning in synonymous with each other while they are different fields. And there is also an interaction of all these fields. So imagine we have a circle of AI here and a circle of data science, and both of them are having an interaction. So AI, like machine learning is subfield of AI, and deep learning is a subfield of machine learning. And then in artificial intelligence, you also have computer vision and NLP, which are having interaction with machine learning and data science both. In itself, data science is having exploratory analysis, which is not AI. Like if I see what is the distribution of my data, or if I see the missing values in my data, or what's the noise in my data, that's not machine learning. I'm not using any machine learning algorithm, but that is still a data science. That's still part of understanding the data. Through data wrangling techniques, I'm still mining the data, but that's not machine learning. I'm visualizing the data. I'm visualizing the patterns in the data. I'm using various graphs and ways of visualization. Again, not a machine learning, but a part of data science. So that's how AI and data science are having an interaction. And mathematics, programming, and statistics are key underlying knowledge area of all these streams. So that's it for today, guys. I hope you liked the session. And we are, as I said, we are going to have so many sessions on each of these fields in the future. Thank you so much.